What is up, mathletes? Welcome back to the episode of Math with Dr. Math, and today we're going to be talking about solving those systems of equations, and we're going to be using your favorite addition method. Alright, mathletes, so when we're solving these systems of equations, we have 5 different ways of solving these systems. The first way we're going to look at is graphically. All right. The second way is known as the addition method. All right. Some people will call it the addition method. Other people will call it the elimination method. And we'll see today, right, why they call it the elimination method. So this is the one that we are going to focus on today, right? But then you have the substitution method. Then we have Kramer's rule. And then we have the Gauss-Jordan method, also known as matrices. All right, folks, so don't go anywhere because today it's going to be hot. All right, mathletes, so first things first, let's go ahead and make sure you understand and you know the name of this method. So when they ask you, so this is the addition method or the elimination method. But for the most part, we'll just stick to the addition method of calling it that. All right, so number one, first thing you need to do is make sure that your equations look like this. AX plus BY equals C, right? And this has a name. So whenever you hear your instructor or a textbook or whatever you're using ask for standard form, that's what this is called right here. This is known as standard form. So write that down, all right? So this is standard form. So don't get confused, don't overthink this. All this means, right? So don't get confused here. All this means is that the X term and the Y term, they're on the same side of the equal sign. So you're gonna have the X and the Y on the same side, and your constant, your number, is gonna be off on the other side. And it doesn't matter as long as your X and Y's are on the same side. Because just think about this logically. If you have an X in your life, you usually ask yourself, why? All right, so let's look at the goal here. So our goal, number one, is to eliminate one of the variables from both equations. And you're gonna do this by adding the two rows together. So that's the first thing we're gonna do, and I'm gonna show you exactly what that looks like, all right? So don't panic. Number two, we choose either variable to eliminate. So you're gonna choose either the X or the Y. Later on, you'll get used to working with different variables, but right now we'll just refer to it as X and Y. But again, the letters don't matter. Choose one of them, get rid of it. All right, get rid of one variable. All right, step 3, you're gonna choose that variable that's the easiest to get rid of. So is the X easier? Is the Y easier? And I'm gonna take you through my thought process so that you know. But what's nice is even if you choose the harder one, you'll still get the same answer. But I wanna work smart, not hard. All right, so go ahead and copy down this example number 1. So we have 2x minus 3y equals 12. And our second equation, we have 3x plus y equals 7. So there's our system. You have 2 equations, right? 1 equation, 2 equations, and you have 2 variables, an x and a y. So notice, right? Notice that the x terms and the y terms are lined up and they're in standard form because our constants are on the opposite side of that equal sign. So this is what's known as standard form. This is the most important step, right? Is that starting point, your foundation. All right, so let's get started, mathletes. So first things first, you're gonna choose a variable to eliminate. And from this equation here, and what I'm gonna do is I'm gonna choose the y, right? Because in my opinion, it's easier to get rid of the y's. Because here's my thinking, right? It's all about the logic. This has a -3 in front of it, this y, and this y has a 1. So I know that it's easier to get the numbers in front of y to be the same number with opposite signs than it is for the x's, right? It's not going to be too hard for the x's, but it's just much easier in this case to get the y's the same. So let's actually do that. So step 2, what we're going to do now that we made that decision is that you're going to multiply that bottom equation by 3. because our goal is to get these y values to be the same number but opposite signs. So you want them to be the same number and the opposite signs. Why? That's what you should be asking yourself. All right. So let's go ahead and multiply everything by 3. Right. We're going to distribute that 3, and what that gives us, right? Notice that top equation did not change. That top equation did not change. That bottom equation, you multiplied everything by 3, so it became 9x plus 3y equals 27. So make sure that you tell yourself everything gets multiplied by 3, right? You get a 3, you get a 3, you get a 3, right? And when you do that, and the reason I'm highlighting that is because so many people forget about that 7, all right? Don't forget about the other side. And so this is what you get. This is what we get right here, right? And look at what we have here. You have a negative 3y and a positive 3y, right? That's exactly what you want, because you're gonna see that these two are gonna eliminate, right? Because we're gonna add them together. And when you do that, those two are gonna cancel each other out, and that's what you're after, mathletes. You want one of the letters, the variables, to cancel each other out. If not, you know you've made a mistake. So let's go ahead and add 2x and 9x, and that's how we get the 11x. And then the 12 plus the 21, that's what gives us the 33, right? And now the easiest step, we're gonna divide both sides. If you wanna see that, we're gonna divide both sides by 11. And that's how we get x equals 3. Make sense? All right, mathletes, don't get too happy yet, right? Don't start doing your salsa dancing yet, right? So we haven't solved the system yet. All you have is one variable, right? So all we did is find out that x equals 3, right? So you're not done, right? We still have not found the value of y. So you're not finished, because you want both the x and the y, all right? So let's do this. So notice we have our original equation, right? We have your original equations. Now we're gonna substitute the 3 for the x, because we know x equals 3. So wherever I pick one of the equations, and what I've done is I said, I'm gonna call this equation A, I'm gonna call this equation B, just so you know which equation I'm referring to, so you don't get lost and end up like this guy.
What the hell? What the hell, you idiot! Oh my god! Oh my god! What the hell are you doing? Oh my god, you're mad. Like, you're absolutely... I thought I was clever. Do you understand this idiot? You're a complete idiot.
All right, so equation A, that's what I'm gonna use. Does it matter? No, it does not, right? So I'm gonna use equation A, and I'm gonna, wherever I see the x, because I know x equals 3, I'm gonna plug in that 3. So that's what's going on right here. So now we'll go ahead and plug in the 3. So you get 2 times 3 is 6, minus the 3y equals 12. And now all we're doing is solving this equation, right? And you're gonna solve it for y, right? That's all we're doing. So I'm gonna subtract 6 from both sides. That's what we did here. And so we're left with negative 3y, and we subtract equals 6. And now the easiest part, we're gonna go ahead and divide both sides by negative 3. So, boom, y equals negative 2. So now you know what x is, and now you know what y is. So our solution, our final solution, is the point 3 comma negative 2. All right, so let's go ahead and let's look at another system here. We have 2 equations, right? I'm gonna go ahead and label them equation A, equation B, and I'm gonna make sure they're in standard form, right? Once they're in standard form, and again, standard form, x and y are on the same side of the equation, your numbers are on the other side, and then make sure your x's and the y's, they're lined up, right? So, which equation should we eliminate? And in my opinion, it's much easier to eliminate the x's, right? Why? Well, I noticed that I could multiply equation A here by a negative 2. And once I do that, I'm gonna get the x's to cancel each other out. So let's actually do that so you can see what I'm talking about. And this is just gonna come with practice over time, right? So I'm gonna multiply that top equation by -2. That bottom equation, notice, it's staying the same. Nothing's happening there. So when I distribute that -2, I get -2x plus 6y equals -26. Again, don't forget to multiply everything by that -2. And this one's quite nice, right? Because now that -2 and that 2x, they're gonna cancel each other out just like we want. And look what we have. When you combine your like terms here, you're left with the y. And so we end up with y equals +4, right? So right away, this problem worked out much nicer. Is it always gonna work out that way? No, but again, if you use this method, you're gonna get there eventually. This one was nice because at the end, I didn't have to do any division and it worked out nice. So the big question is, are we done? All right, so now what, right? Now what do I do? Well, notice we just solved for y. So now we have to go and solve the system for x. So I'm gonna go ahead and I copy equation B over again. So there's equation B here. And I'm gonna substitute 4 wherever I see the value of y, because I know y equals 4. So wherever I see a y, I'm gonna put my parentheses and I'm gonna plug in that 4, right? And again, does it matter which equation you use, equation A or equation B? No, I just went ahead and chose equation B. All right, so let's go ahead and solve for x now. So you have 2x minus 20 equals -22. Well, we're gonna solve for x. I'm gonna add 20 to both sides. And so we're left with 2x equaling -2. Don't forget to divide both sides by 2 and we get x equals -1. So if I have two lines here, what I'm really looking for is where are those two lines going to cross? And so what I found is they're gonna cross at the point, notice x is -1 and y is 4. So this solution, x comma y, this is gonna represent the point where the two lines intersect, and that's our goal, right? So make sure that you write that down. So usually people on a test, they wait to get their test back and they say, you know, did I do it right? You don't have to wait, right? There's always a way for us to check. So all we're gonna do is we're gonna copy one of the equations. So I'm gonna copy equation B over again, and I'm gonna substitute my solution. So wherever I see x, I'm plugging the -1 that I found, and wherever I see y, I'm plugging in the 4. And after doing the math, right, after evaluating the equation for those values of x and y, what I'm gonna see is that both sides are gonna be equal to each other. So what that tells me is that my solution is correct. So you never have to wait for your teacher to check your work. You could always check your work yourself. All right, so what we wanna do here is talk about the potential mistakes that people make. So we're gonna find the error in this problem here using the addition method. All right, so what I see happening often, which you have to be careful with, is people will see these equations and right away, they're going to add their equations, right? The two equations, they just straight up and they jump in here and they start adding, right? And so the mistake, right? Let's look at the mistake here, is you are not, right, supposed to add the equations together yet, right? Because what our goal is, your goal is to eliminate either the x or the y, and here we have done neither. We haven't eliminated the x, we haven't eliminated the y, so we haven't done anything that's gonna be helpful. So make sure, right, that you really understand the process, because I see a lot of people, they do this and then they're like, okay, what do I do next, right? And so they get themselves in a bigger hole. Don't do that. All right, so in summary, go ahead and copy down these steps. This is what we did. So remember, we chose the easiest variable to eliminate. You choose the x, y, a, b, whatever letters they're using, choose the easier one. If necessary, you're gonna multiply one or both of the equations to eliminate that variable, right? That's your job. So after you have the numbers in front of either the x the same but opposite signs, or the numbers in front of y to be the same with opposite signs, then you could add the two equations together, because that's how you're going to eliminate either the x or the y. Then you're going to end up solving for x or y. Once you have that variable solved for, you're going to use it and plug it into one of your first equations. You choose the equation. I always try to choose the easier one. And then last but not least, don't forget to check your answers to make sure that you did everything right. All right, mathletes, so those are the pro tips for you today. And before you leave, make sure you subscribe, like, and I have some practice problems here for you, right? So what I want you to do is use the elimination method and comment down below what your solutions are, all right? And then we'll see how well you understood this video. All right, folks, don't forget to smash that like button, subscribe, and we'll see you in the next video. Peace.